Take it away. You were also muted.
Oh, I just realized that. Sorry. Okay, let me get myself sorted again. Thought I was on top of it. There we go.
Perfect.
All right, well, thanks so much, everyone, for being here. As I said, my name is Victoria Donovan. I'm a postdoctoral researcher at the University of Nebraska. Today, I'm going to be talking to you about an accumulation of a bunch of research I did during my PhD and some of the work that I'm continuing to do during my postdoc here at UNL. My talk is basically going to be about fighting fire with fire. How can we reduce wildfire risk in rangelands? So I'm sure that many of you are used to seeing these types of images and news stories now. We know that large wildfires are increasing across the US. And in 2017, we published a paper that identified increasing wildfire across the US Great Plains. So we found a 400% increase in the total hectares burned by large wildfires and a 350% increase in wildfire number. And we found that a lot of these increases, that these increases were occurring across the majority of the Great Plains. So I've broken the Great Plains down here into different ecoregions. And everywhere that's colored in red had some sort of increase. And the darker red areas show where we had a greater increase in wildfire number and hectares burned. So you can see that most of the Great Plains is experiencing an increase, but a lot of our greatest increases are occurring kind of in these western regions of the Great Plains. So once we found this out, of course, wildfires can be really beneficial in a lot of ecosystems, but they also can pose a risk, as we see out in California with wildfires right now. So a lot of people want to know, how do we fight this surging wildfire activity to protect our homes and our property? And to do that, we really want to look at factors that fire is dependent on. So we know that fire needs ignitions. We need appropriate weather and climate that's conducive to fire, and we also need fuels for our fire to burn. And there's been a bunch of research done now looking at ignitions, particularly the difference between lightning-started fires versus human ignitions. And I've taken this map here from Bulch et al. In 2017. And you can see here the different size circles are representing a different number of fires that were assessed. So the larger the circle, the more fires that burned in that location. And the colors are representing the percentage that were human ignitions. So if it's more red, you're looking at more human ignitions. So if we focus here on this Great Plains area, you can see that clearly we have a large number of human ignitions occurring, but most of them are occurring on this eastern portion of the Great Plains rather than in the western area where we're seeing a lot of those increases in wildfire number and hectares burned. So we know that this isn't the only factor that's driving some of these changes. We also know that climate plays an important role in fire. In the western US, we know climate change is a huge factor driving a lot of those increasing wildfires. And here in the Great Plains, we see that as well. If you look at this frequency plot I have here, we're looking at the relationship between fire frequency and PDSI, or the Palmer Drought Severity Index. And this indicates to us an amount of drought. So the lower the value, the more extreme the drought condition. And you can see that a lot of our wildfires are occurring under drier conditions, which makes sense. I've plotted out a bunch of wildfire perimeters here from 2000 to 2012, and I've color-coded them based on the drought conditions that they occurred under. So you can see on our eastern portion, where we generally had the most human ignitions, we also have a lot of wildfires occurring under these near normal and moist conditions, whereas in the western Great Plains, we see a lot more wildfires are occurring under more severe drought conditions. So clearly drought is also playing a role here in the Great Plains and influencing our wildfire patterns. It's something we need to do more research in. But we also know that drought can play a really important role in forested systems where fuels are really abundant because they influence the availability of those fuels to fire. Whereas in grassland systems, our fuels tend to be a lot more limited. And so the distribution of fuels and their abundance can have a greater influence on fire than weather and climate. And so we wanted to focus a lot of our work looking at fuels. Another reason why we're interested in looking at fuels is because it's a lot easier for an individual landowner to manage fuels on their landscape than it is for them to individually try to manage global climate. So I'm going to focus on fuels and their impacts with wildfire. So what we wanted to do with one of our studies that was recently published in Remote Sensing, we wanted to track the relative wildfire risk across different land cover types in the Great Plains. So in this map here, all of these red polygons are looking at wildfire perimeters. And then we have our different colors here for different land cover types. So we looked at herbaceous vegetation, woody vegetation, crops, pasture and hay fields, and developed areas. And what we found is that crops, pasture and hay fields, and developed areas generally have a very low wildfire risk, whereas herbaceous and woody vegetation have higher wildfire risk, which is something that we would generally expect. What we were interested in is that you can see, if you look at the size of these two bars, is that woody vegetation actually burned disproportionately more than any other land use type in the Great Plains. So it held the largest or the highest large wildfire risk in the Great Plains. And we also wanted to track the relationship between the amount of cover of each of these land use types and how that influenced the probability of fire in a landscape. And so what you can see here, looking at herbaceous landscape cover, we see that you need about 60 or more % of your landscape covered in grasslands. So you need relatively contiguous grasslands in order to have this elevated high or large wildfire risk. Whereas when we look at woody vegetation, you can see that large wildfire risk increases as soon as about 20% of our landscape is covered in woody vegetation. And so what this suggests to us is that we only need a small amount of woody encroachment in our landscape before we see this elevated large wildfire risk. Now we broke these patterns down again into those different ecoregions I showed you from the first wildfire study. And you can see clearly there's a lot of variability going on here. In general, we see that, again, either herbaceous or woody vegetation or both have the highest large wildfire risk across ecoregions. But if we focus specifically on the ecoregions where we saw the greatest increases in large wildfire, you can see that almost all of them, with the exception of the high plains here, had woody vegetation as the predominant vegetation type with high large wildfire risk. So why do we think that woody vegetation is so high risk for wildfire? Well, we think it's because of the extreme wildfire behaviors that are created by woody vegetation. It makes fire a lot more difficult to suppress. And you can see that pretty clearly in this image that was taken by Direct Twidwell. You can see these flame lengths in grasslands compared to flame lengths that are occurring in this cedar tree that's alight. And so clearly this cedar tree fire is going to be more difficult for us to suppress and control. And we know that here in the Great Plains, a lot of our wildfire regime is dictated by human suppression. So it makes sense that where it's more difficult for us to suppress fires, it's also going to be where we see more large wildfires occurring. Now, the reason why high wildfire risk in woody vegetation is a little bit intimidating is because we know, and a lot of speakers have talked about, how woody encroachment is occurring across much of the Great Plains. I'm going to pull the example here from a study just published by Dylan Fogarty, and he tracked increases in woody vegetation across Nebraska. And so you can see in this map here that anywhere that's red is a rangeland that had an increase in woody vegetation cover between 2000 and 2017. So you can see that a huge amount of our rangelands in Nebraska are being affected by woody encroachment. And just to give other examples here, he's plotted out the change in woody cover through time for all of our biologically unique landscapes in the Great Plains. And you can see that in almost all of them, we're tracking increases in woody vegetation. We know that our landscapes in Nebraska that we think are generally going to be the most resilient to woody encroachment are also experiencing changes in woody vegetation. So I'll give you an example for the Nebraska sandhills. We tracked established cedar encroachment from eastern red cedar windbreaks across the sandhills, and we found that about 25% of windbreaks had eastern red cedar spread. So we know that even in places like the sandhills, like Reinhardt just said, some of these really intact grasslands, we are seeing increasing woody vegetation. So how can we potentially fight this increasing wildfire in the Great Plains? Well, the key path forward from this research is we need to control woody vegetation. And there are a number of different ways that we can do this. For instance, we can use mechanical fuel treatments. But as Dr. Ahmed mentioned in his talk yesterday, mechanical fuel treatments are extremely expensive. They're not very economical, and a much faster and more natural way to remove woody vegetation from our landscapes is using prescribed fire, which is why I've titled my talk, Fight Fire with Fire. So we know that indigenous stewardship of the land utilized frequent fire to maintain grassland systems before Euro-American settlement. And the majority of the Great Plains had a mean fire return interval of between 2 to 12 years. So we burned really frequently. We know that once European settlers came into the Great Plains, we saw a massive shift in fire patterns where we eliminated almost all fire from the Great Plains. And we also associate this fire suppression with our increasing woody vegetation. So we're seeing a lot more woody encroachment now that fire has been removed from the landscape. So I'm just going to go through a couple common concerns. Maybe these, since we've been talking so much about prescribed fire in this conference, a lot of people might just kind of scoff at these concerns at this point, but I'll go through them. You know, one thing that holds people back in terms of utilizing fire as a tool is that they're concerned that it's going to drive large losses in grassland vegetation. And so we conducted a study tracking grassland recovery and a bunch of different vegetation types recovery across the Great Plains. So what we did is we collected information on vegetation through time across all wildfire perimeters in the Great Plains from, I believe, 2000 to 2012. And in these plots, what I've done is I've averaged response across all wildfires so we can look at a Great Plains-wide responsive vegetation. This gray bar here is representing our pre-fire range of variation. So how much variability in cover, in perennial forb and grass cover in this case, was there 10 years before the fire occurred? And then this red line represents the time that the wildfire occurred. And what we wanted to track was how rapidly are we seeing, and do we see at all, that vegetation is returning to this pre-fire range of variation, which would indicate recovery. And so you can see here really clearly that we have rapid recovery of perennial forbs and grasses, and this response is so consistent across wildfires in the Great Plains that we can track it even at this large scale. And I've also just put a response for bare ground here too, so there's a lot of concern about desertification following fire. And so you can see here our bare ground spikes immediately following our wildfire, but we see it return to this pre-fire range of variation following a year or two after fire. And we broke this down into multiple different scales as well. So just like in our other studies, we looked at these different ecoregions in the Great Plains, and you can see that across all our Great Plains ecoregions, we see rapid recovery of perennial forbs and grasses. And we conducted these also by isolating fires that only burned under extreme drought conditions, and we still found rapid recovery. I'll give you an example here of a wildfire that burned in the Nebraska Sandhills, the Region 24 complex fire, and it burned under extreme drought conditions. And we kind of expect the Sandhills to be more sensitive to fire because of the sandy soils and the dry conditions there. So it's thought that if we have a fire that burns under drought in the Sandhills, it can lead to active blowouts and desertification. But you can see that after this fire under extreme drought conditions, we have rapid recovery of our perennial forbs and grasses. At the same time, we know that trees can be quite sensitive to fire. So just an example from the same study, we tracked trends from a local scale, wildfire scale, and ecoregion scale, and you can see that we saw these persistent declines in tree cover. And similarly in Nebraska, we know that fires are influencing woody cover. So I'll give some examples here from the Pine Ridge and the Middle Niobrara, where we know we have a lot of ponderosa pine cover. And in these maps here, you can see these maroon outlines represent our wildfire perimeters. So you can see this patchy loss of trees in blue associated with fire patterns. But it's not just wildfires that are able to control woody vegetation. We know prescribed fires can do this as well. So for example, in the Les Canyons of Nebraska, landowners are working together to apply fire onto the landscape. And you can see in these black polygons here are outlining some of our fire perimeters that have been applied in the Les Canyons. And you can see that they are capable of halting encroachment into this area and or reducing some of our woody vegetation as well. And when we track the change in tree cover through time, we found that we're seeing this slowing down and halting of this increasing trend of tree cover we associate that with the additional or the increasing application of prescribed fire in this area. So to sum with all that, all I really want to say is that fire does not drive declines in our grasses, but it can drive declines in woody vegetation. Another common concern is that prescribed fire can be really risky, and so a lot of people don't want to utilize it. So I'm going to pull an example here. This is actually a study done by Drac Twidwell that was published back in 2015, but it's kind of an interesting little example. He compared using different proxies of how we can, basically different rangeland management proxies. There we go. So for instance, we can look at firefighters compared to logging workers and look at the rate of fatal injuries and see how dangerous these different professions are and kind of compare them to fire management versus mechanical tree removal. And you can see an example here, the rate of fatal injuries. Clearly, there's a lot less risk for firefighters versus someone who's doing logging or using construction equipment. When we compare the number of fatal injuries associated with wildfire versus prescribed fire, you can see clearly there's a much higher risk associated with wildfire. And so utilizing prescribed fire to help decrease our risk of these large wildfires seems like a clear and great option.
3 minutes.
Thank you. The other concern is that we'll see spot fire, both from wildfires and prescribed fires. We can see spot fires occurring. And basically what this is our fuels are burning, we have burning embers lifted into the air, and then the wind will carry those burning embers to a new location, new receptive fuels that can alight and start a new fire. And if they've traveled too far, we might miss them during prescribed fire, or alternatively, during wildfire, it makes it much more difficult for these fires to contain if they travel a long distance. And so I have been working right now on tracking patterns in maximum spotting distance, so how far we can predict a spot fire might occur relative to wind speed and then these different levels of invasion. So a grassland in this plot is plotted in yellow. In orange, we have early invasion grasslands, and then in red, we have eastern red cedar woodlands. And so you can clearly see here, our spot fire distance is much smaller if we're burning in a grassland compared to if we wait for cedar invasion into our grasslands. But you'll also look at this little gray square here. If you look at the wind speeds under which we're burning under prescribed fire, you can see that these differences are not nearly as large. We're sitting under a mile for our maximum spot fire distance. So if we use prescribed fire in any of these landscapes, we're greatly decreasing the risk of this fire spreading and escaping to larger areas compared to if we wait for these more extreme wildfire conditions. And I've just plotted this out in a different way here in the Les Canyons of Nebraska. These black polygons represent prescribed fire perimeters that have been applied. And the different gray areas here are non-receptive fuels, so fuels that aren't able to alight. And you can see that under prescribed fire conditions for any of these different categories, we aren't traveling nearly as far as if we would be under extreme wildfire conditions. And something that I find interesting is this region here where, we can have this barricade of non-receptive fuels, but under wildfire conditions, we can spread to whole new areas. So how should we fight surging wildfire? Well, I'm suggesting that a great path forward is for us to manage fuels. Particularly, we need to manage woody vegetation. And the best path forward for us to do that is to use prescribed fire. Prescribed fire will help reduce fuel buildup in our grasslands, which also hold wildfire risk. They'll prevent woody encroachment into grasslands, and they also can help us to remove woody vegetation from our grasslands. And the other thing is just to note that fire is an important ecological process in our grasslands. So by using this method, we're also reinstating this ecological process, which is really important for our grassland conservation. Thank you very much.